everyone, welcome to my video, and today we are going to talk about walking. So everyone knows that walking is an essential part of our life. We are born, we learn to walk, we walk to school, then to work, and we are going to walk for ideally the rest of our lives. But some of you may be wondering, what's so special about it that you decided to make a video dedicated to walking? So now let's delve deeper on why walking is just so important. Okay, so about walking, we're going to observe the steps that Hong Kong people, Americans, and Indonesians take in a day. So basically, we're going to find their daily steps here. Okay, so firstly, covering the importance of walking, we can see that walking improves our physical health by improving heart health, strengthening muscles and also bones. It aids in weight management and also boosts immunity. And second, it improves our mental health by reducing stress, enhancing our mood, sharpens focus, and promotes better sleep. It also helps prevent some diseases because regular walking lowers the risk of heart disease, diabetes, and certain cancers while increasing lifespan. And lastly, it's on our environmental and social benefits. As we walk, we can foster social connections and reduce carbon emissions because we're not really emitting any fossil fuels. And next, we're going to cover first on the life expectancy of people from each of these countries. So, Hong Kong has a life expectancy of 85.63 years on average for their citizens. America on the second has 79.46 years, and Indonesia on the last place has 71.29 years. So we're going to try to find out how the length of life expectancy here has a correlation towards walking. And just to prove our point here on why we need to walk. So firstly, we can try to track the steps first. We can see here I have found data from 30 people from Hong Kong, America, and Indonesia, and the steps that they take on the daily. Here are the three groups, which is our countries, and the amount of data, which is 30. So, firstly, we're just going to pop this data here on Excel, and we're just going to try to do a data analysis function. So, based from the statistical analysis here, the daily step counts in Hong Kong has a mean of 6,880 steps per day out of the 30 people sampled, with a median of 7,000 and a mode of 5,600. This basically indicates a fairly balanced distribution of activity levels. The least amount of steps as suggested by the data analysis is 3,600, while the maximum amount of steps is 11,600. The standard deviation of 1945.71 highlights the moderate favorability, while the range of 3,600 to 11,600 steps demonstrates the significant diversity in activity. The kurtosis of -0.24 suggests a slightly flatter distribution, and the skewness of 0.20 indicates a slight positive skew, meaning more people take steps slightly below the mean. And we also have this box plot, which shows that the interquartile range spans from approximately 5,600 to 8,000 steps, which captures the middle 50% of the data, while the minimum and maximum values of 3,600 and 11,600 respectively lie within the whiskers, indicating that there are no extreme outliers. Overall, this box plot reflects that there is moderate physical activity levels with a small variation across the Hong Kong population. And next, we have the statistical analysis for America. The daily step counts in America shows a mean of 4,774 steps per day, and it also has a median of 5,433. Unlike Hong Kong, there is no mode, so it means that there is no single value that is repeated most often. The standard deviation of 2148.74 highlights a high variability in activity levels, with a range spanning from a minimum of 760 steps to a maximum of 8,092 steps. The kurtosis of -0.96 suggests a flatter and broader distribution, while the skewness of -0.39 indicates a slight negative skew, meaning that there are more individuals that take steps above the mean. This distribution reflects diverse activity levels, with many participants reporting either significantly lower or higher step counts. Overall, the data shows lower average physical activity compared to Hong Kong, with greater variability across the sample population. And also, we also did a box plot for America. So the box plot illustrates the distribution of daily steps taken by 30 American citizens. The median number of steps is approximately 4,500, as we can see on the small X here, with an interquartile range spanning from 3,000 to 6,500 steps. This indicates that half of the participants that took steps within this range. The whiskers extend from around 1,000 to 8,092 steps, 1,000 being the minimum, 8,092 being the maximum, showcasing variability in daily step counts. While some individuals were highly active, exceeding 8,000 steps, a significant portion falls short of the recommended 10,000 steps per day. The mean slightly higher than the median suggests a right-skewed distribution. The box plot analysis suggests that the daily step counts of 30 American citizens vary significantly. And lastly, we have the statistical analysis for Indonesia. So this analysis shows a mean of 3,513 steps for 30 Indonesian citizens. And also it has an indication of a standard deviation of 1971.058091 steps, which suggests that it has a significant variation. And the median of 3,250 suggests that half of the participants took fewer steps, and the positive skewness of 1.004865 confirms a right skewed distribution, meaning a lot more people take steps below the mean. The range of 7,890 steps with a minimum step count of 1,000 and the maximum step count of 8,890, it emphasizes the variability of the samples. The kurtosis of 0.93 indicates a moderately peaked distribution with some extreme values, and we can see that the steps taken are less than Hong Kong and American citizens. And here's the box plot that represents the interquartile range, showing the middle 50% of the data, with the lower boundary around 2,500 steps, which is on the 25th percentile, and the upper boundary around 4,250 steps, which is on the 75th percentile. The median represented by the line inside the box is at 3,250 steps. The whiskers extend from the minimum value of 1,000 steps to 8,890 steps, representing the range of most of the data. However, the right-skewed distribution with a mean higher than the median and an outlier exceeding 8,990 steps reveals that a small number of individuals were significantly more active than the majority. The box plot analysis suggests that the daily step counts of 30 Indonesian citizens vary significantly. So, on to our first hypothesis, which is the mean comparison between America and Indonesia. For our null hypothesis, or HR, the mean value of data for America is equal to the mean value of data from Indonesia. And the next one is the alternative hypothesis, which is our H1. The mean value of data of America is not equal to the mean value of data from Indonesia. So we can try to do a solution to prove our hypothesis. Which one is the right one? So we can start by trying to find the mean of Hong Kong. We can try to divide the total amount of steps taken by these 30 recipients by the amount of recipients taking the survey. So we can do 206,400 for our total and divide by 30, which equals a mean of 6,880 steps. With also mean of America, we can try to find it by using the same formula, and we are going to get a result of 4,774 steps, and mean of Indonesia with 3,513 steps. But since we're just going to compare between Indonesia and America for now, we are going to only find the variance of Indonesia and America, which we can find by the standard deviation with the power of 2. Here, the standard deviation of Indonesia is as stated on the PPT, which is 1971.058091 with the power of 2, which has a result of 3885070, and variance of America with the same formula we can find, which results to 4617065.586. And then we're just going to pop this into our t value formula. We can try to find it by subtracting the mean of Indonesia with the mean of America. and it has and also divide it by the square root of our Indonesian's variance divided by 30, which is like amount of recipients, plus the variance of America divided by 30, and it equals to minus 2.37. And next, we need to also find our degree of freedom to further emphasize which hypothesis is going to be correct. And we can find it by finding the basically S1 power of 2 minus N1 plus S2 power of 2 divided by N2. And here we can try to find it and also kind of like put the power of 2 again after we add it. And then also on the denominator, we're going to have S1 power of 2 divided by N1. And then we're just going to put it in bracket and power it by 2 and use N1 minus 1. And here N1 means that there's like 30 people, right? So we're just going to subtract it by 1. So that's why we have 29 here in our formula. And so by this formula here that we've put all of our data in, we can find that our degree of freedom will be around 57.99. So we can round this up to 58. And we have to find alpha divided by 2, so it's 0.025, and we can find that the critical t-value is 2.001. And so the alternative hypothesis is correct, which is 81 equals to mu America is not equals to mu Indonesia. Since our calculated t-value is minus 2.37 and the critical t-value is about 2.001, and since our critical t-value is less than 2.002, we can also reject H0. And we can also use the Excel p-value test as the formula we can see on the PPT right here. It says that the p-value is 0.02123, which is less than 0.05, which we can find here on our alpha. So there's sufficient evidence to conclude that the mean values of America and Indonesia are significantly different at the 5% significance level. And next is our second hypothetical statement, which is the mean comparison between Hong Kong and Indonesia. So our null hypothesis would be the mean value of the data on Indonesia is greater than or equal to the mean value of data from Hong Kong. And the next is the alternative hypothesis, or H1, which states that the mean value of data from Indonesia is less than the mean value of data from Hong Kong. Let's try to find out. So here's our solution. First, we're going to find a variance. We're going to take standard deviation of Indonesia and the amount of recipients from Indonesia to find our variance, which is 129,502.33. And we're just going to do the same for Hong Kong, divide the S power of 2, divide by 30, which is the amount of recipients. And we're just going to get the value of 126,193.1. And after that, we're just going to find the t-value just like we did before. So we're just going to do S1 per N1 with the S1 we powered by 2 and S2 powered by 2 divided by N2. And we're just going to add this together and power it by 2. And then we're going to divide our S1 power of 2 divided by N1 with power of 2. And S2 power of 2 with the N2 with the N2, and from both of these we can divide it by N1 minus 1, which is why we have 30.3 minus 1 here, 29, just like what we did before. And we're just going to put power of 2 on both of these values, and then we can get the degree of freedom of 57.99. And we can use Excel's t-distribution function for a one-tailed test, since this hypothesis is one-tailed. And we can use our t-value and also insert our degree of freedom and put through there. And we can find out that the answer is 5.48 times 10 with the power of minus 9. So that's a very tiny number. And so it turns out that the alternative hypothesis is correct, which is H1 equals to mu Indonesia less than mu of Hong Kong.
Since p is less than 0.05, we reject the null hypothesis. And basically, the mean of Indonesia is statistically less than the mean of Hong Kong. And so, based from this, we can conclude that since we can find out from the data before here that the mean values of Hong Kong, America, and Indonesia, with Hong Kong with the first of the steps count, which is the mean of 6,880, and America with a mean of 4,774, which is placed second. Indonesia on third, 3,513, actually has a correlation with the life expectancy. As you can see, Hong Kong also places first on the life expectancy, America being second, and Indonesia being 71.29 years, which highlights more on why we really need to walk and how important walking is for our health and life expectancy. So everyone, thank you for watching my video, and hopefully this really helps on how we can learn about trying to prove our hypothesis, both null hypothesis and alternative hypothesis, and also educate you more about how important walking is based on real statistical data. Thank you everyone, and we'll see you next time on the next video. Bye!